121, we're up to mod 4, which is acquiring evidence. So let's take a look at that. All right. So there are organizations that have tried to define what you need to make an appropriate computer forensic lab. You see a few of them here. The American Society of Crime Laboratory Directors, an ISO international standard, the Scientific Working Group on Digital Evidence, and so on. These guys have just made best practices and rules for making a computer lab. There are private sector computer labs too. There's the public sector ones the police have, and then there's private sector ones like, for example, one I mentioned before, DriveSavers. DriveSavers will recover data from a damaged machine. They will also collect forensic data and then create a appropriate report and send an expert to court to testify about that data. You can outsource forensic work to them. They will cheerfully do it. It's expensive, but they'll do it. But all forensic work is pretty expensive. So anyway, banks and credit card companies have their own internal practitioners, people that have a lot of forensic work to be done. And as I mentioned before, there are different levels of forensics. One common area is e-discovery, which is responding to a court order requesting information. In that case, a plaintiff has a complaint about something somebody did, like Oracle had a complaint that Google had used their Java product without paying royalties. And so Google was issued a discovery order, say you must give us all the documents about the way you used Java in Android for the last 5 or 7 years. And that's a big job, and that's what they had to do, find all that electronically stored information, like email and Word documents and so on, and deliver it in court. Sarbanes-Oxley was passed in response to Enron, I believe, and the point here was, as I was mentioning about Elon Musk earlier, if you run a publicly traded company in America, you are not allowed to lie about your financial state. You aren't even allowed to conceal your financial state. You are required to issue statements about your financial condition so investors have a chance to know how you're doing. And so they must maintain electronic information in case they get sued. And the big one I mentioned is GDPR. If you have European customers, you have to obey the European privacy laws, which are very strict, and they're passing more of them all the time. In Europe, they really care about privacy, far more than America. And they've greatly improved the privacy of Americans by pressuring American companies into obeying European privacy laws. All right. This, by the way, is another thing Twitter's doing wrong. Since Elon Musk took over, he's refusing to pay any of the bills from before, and he's refusing to delete data for European customers when he is required by law to delete that data. But he's ignoring a whole lot of his responsibilities because I think his opinion is the company's going down the drain, and I might just declare bankruptcy, and then all these questions don't matter. So he's not paying his rent, he's not paying the server fees to keep the servers up, he's ignoring all bills for a while, and all legal requirements. And we'll see how that works out. But it might work out, because it might be that the collapse of the company for pure financial reasons is a bigger problem for him right now. Anyway, all right, so here's some issues. Evidence acquisition is the main thing. You want to acquire data from all the devices that are irrelevant, and you want to store a copy of it so you preserve the evidence. That's the first job. It's called data acquisition. And your staff should be able to do this, like image software, and perhaps cracking passwords and decrypting drives is helpful. You get email, of course. You use a program to parse the email and make it easier to read. If you have, after a while, you will have a lot of physical devices, hard drives, cell phones, and things that are evidence. You must have a safe or a locked evidence room to keep track of those things. You must have a labeling system and a catalog and a logbook keeping track of where they've been and who's been looking over them. So if 5 years later you have to go to court, you can prepare proof that we obtained the evidence and this person took responsibility for it, and then this person did, and then this person did, and we made sure that nobody tampered with the evidence right up until now. This is why one thing people often forget when they start forensic consultancies is they forget to charge their client for storage. Because whether your client agrees to it or not, you're going to have to hold on to that stuff for like 5 or 7 years, because often you think it's over and then there's another lawsuit that needs the evidence again. So you can't just throw it away. And if you forgot to charge the client a storage fee, you're going to be sorry after a while. All right, so you have to have an information management system keeping track of the things, the evidence you found, the reports you made, the letters you wrote, the items you're holding. And you may want to have web pages to deliver this stuff. That's how the FBI does it, by the way. The FBI federal cases, they seize the evidence, they send it to a central location, they image it, and they put it on a server, and they run FTK on the server, and the agents all over the country log into that server remotely and analyze it with FTK. Because It's a whole different issue to just acquire the data, to put it on the cloud server, and then the agents will use FTK to read the emails and stuff because they're the ones that know about the case. But the technical part is done by other people. So you have a laboratory for this stuff, the kind of thing you might have. You have workstations and storage units. And so you have equipment closets, evidence locker, workstations for both PCs and Macs, and a workbench to take things apart and work on them. And these can be pretty elaborate. I've seen the police ones in San Jose, and they have just many stations full of stuff just for cell phones. Get huge box suitcases full of connectors and cables and gadgets to take apart all the different cell phones. So the workstations are here primarily to acquire evidence from devices like hard drives. They should be secured with multi-factor authentication is a good policy. I'm not sure how many people really do that, but it's recommended. If you have the money, you might buy a special workstation just for forensics called a Fred workstation, which is just a powerful workstation designed for this purpose. You can just use any powerful workstation, of course, but they do sell one all set up to go. And you have to have a workbench with enough room to dismantle computers and cell phones and enough lighting and all that jazz. And as I mentioned, the mobile device examination workstation is probably a special place in itself because there are hundreds of different kinds of cell phones out there. And they all have different connectors and different requirements to suck the data off them. And you could easily spend $10,000 on cell phone acquiring stuff. All this stuff can get really expensive. And even after you do that, you're going to have stuff that you can't connect to. There's no end of strange little off-brand devices out there with data on them. You can't possibly have the equipment to get in all of it. So you may have to resort to imperfect measures to get to. Anyway, Graykey, Cellebrite is probably the king of this. Cellebrite is an Israeli company that can hack into everything. I met the CEO of Cellebrite in Sri Lanka, and he told me at the time that they could get into every version of Android and every version of iOS without your PIN, that they had hacked it all. And he said that on stage, so I guess that's true. Their stuff is not cheap. And they restricted the sales of it at that time only to law enforcement agencies, although they were trying to expand to selling it to corporations. But I'm not sure if they do that yet. Graykey is a much cheaper, much more common device that you can get to law enforcement. And all this does is connect through the power plug, and it tries a bunch of keys a bunch of pins until it gets in. Now, normally, if you try 10 pins, it locks you out, but they have some system where they try 9 pins and then they reboot the device and cause it to forget. And then they try 9 more and so on. Is Cellebrite selling to nation states? Yes, they absolutely are. But I haven't heard of scandals in them selling to like a nasty oppressive nation state, so I think they might be more careful than most such companies. There are a lot of Israeli malware companies that sell to really nasty regimes and then try to lie about it. Several of them got taken down recently.
Is the forensic space pretty consolidated? Are there a lot of like small scale independent contractors?
Well, the products, the big name products are made by a few big name companies, but the individual practitioners are often completely single practitioners. A lot of people are just forensic consultants, and they just go by word of mouth. The guy that taught me mostly, Steve Haley, he's hired by the teachers union in Washington State to analyze primarily classroom computers, because this turns out to be so common that it's an entire full-time employment. So many teachers are accused of being pedophiles in high school, K through 12, and the evidence is them looking at porn on the classroom computers, that this is a steady job, examining those computers to see if they've done that. Evidently, a lot of pedophiles do in fact teach in K through 12. This is like the Catholic Church found out, if you have any occupation that involves coming in contact with a lot of children, you will attract some pedophiles. And people are very, very, very upset about that, and they really want to find them. So there's steady work analyzing the evidence and catching them. Anyway, but there's plenty of room out there for everybody. The one big thing I should mention again, I mentioned it before, is though if you ever work for defense, you can never work for the prosecution. You have like a binary choice early in your career. When I joined the High-Tech Crime Investigators Association, which is the Secret Service, it's part of them, their entrance requirement requires you have never worked on the defense on any case, or they won't let you in. So it's not like what I hoped, a purely scientific discipline. It's like you pick one side or the other. Anyway, so that's what Graykey is, and here's other devices. I've heard of these paraben bags, just bags to put your portable device in so it can't reach the internet, to call them Faraday bags. And Cellebrite. Oxygen Forensics is another device that gives you to get into mobile devices. And Blacklight is a big one for iOS. Special devices just to read iPhones. All right. So then you got a field kit. Now at your workstation, you'd have all the goodies. But then when you're going out to a location, so some kind of crime scene or something, then you'll have a miniature portable field kit, and this will have some hard drives to put the data on, a powerful laptop. A Cellebrite UFED is a common device you buy to image a cell phone. Faraday bags, external USB drives and sanitized hard drives, lots of them, so you have places to put evidence that you can connect it to different devices. Xways is a good company with software to help make images and also analyze them to some extent, and more flash drives and such. A mouse jiggler is something you might want just to keep something from going to sleep, because if you have something that's logged in and it sits there without being used, it will go to sleep, and now you need the password to wake it up. And when it's logged in, it's decrypted. When it waits for the password, it might be encrypted, not available. So you often use mouse jigglers. These have become popular during the pandemic. People get them so their boss thinks they're still at work when they're not. Anyway, and you got forms like chain of custody and so on, evidence bags, and various kits to take apart devices, cameras, flashlights, and various tools and markers just to handle the physical issues, all right, and when you go to a crime scene, the first thing you do is record everything. You photograph or make a movie of everything. So you know where everything is, you know where all the cables are, you know what was turned on and what was turned off. You got to have that record. Then you start gathering stuff. But it will matter later exactly where was it, what condition was it when you got it. So a Faraday box or room is a place you can go where all radio signals are blocked. This room is in fact a Faraday cage. There's almost no wireless signaling here typically. It's a little better than it used to be. If you close those shades, it gets really blocked off in here. There's a time when I was going to teach a class where we'd make our own cell phone tower and intercept the cell phone calls. And this is extremely illegal unless you don't let random innocent people get in. And I thought we could do it in here, especially one layer of tinfoil on those windows, and we could do it in here. You would only have signal in this room, so we could practice it. We didn't have the right equipment to do it, though. But anyway, you can do that, and the police do it all the time. And you can download apps to tell you when you're connected to a fake cell phone tower, and if you go to DEF CON, you'll see dozens of them. So in fact, they do it all the time. They call them stingrays. They drive a truck into your neighborhood. They turn this thing on and intercept all the phones for blocks around. It's happening a lot. That's how they do cell phone wiretaps. And it does get a whole lot of innocent people mixed in with the guilty ones. Anyway, then you have an evidence locker, of course. You have to have a place to lock up things where you can go to court and testify that I locked it in there and we have strong controls so I know that nobody messed with it. So a safe is commonly used, something like that. And cabinets, of course, to store all the equipment, documents, binders, textbooks, whatever else you have, and a lot of hardware. Now, you can make an image of a hard drive with something like FTK Imager running software on a machine, but the pros make a lot of images, and they usually get a special device for it. There are special devices that will just connect, make a clone of a drive. There's things that will connect different kinds of drives together, like convert IDE to USB. There's smart devices just to make images like Tableau, which are write blockers. So they cost several $100, and they will lie to the computer and tell it you're connected to a hard drive and you're writing to the drive, but they won't send any real write signals to the drive. So that's write blockers are very important and complicated. And there's things where you just plug in the drive. This one input, this one output, press the button. Okay, this is now a duplicate. That's what people use to deploy operating systems to endpoint devices in companies, and you can use them for forensic purposes too. So the harvest drives are the drives you collect the data onto, and you want to make sure they're clean, no data on them before you put on the evidence, so you don't have to explain away in court why you have the evidence mixed with other junk that is not the evidence. What, are you, an idiot? And unfortunately, the answer would be yes. If I was not an idiot, I would have used a clean drive, and then I wouldn't have to answer an embarrassing question in court. Not that it really matters, but it does embarrass you in court and lower your credibility, and you don't want to do that. And all the tools, of course, to take apart these many screwy computer torque nuts and all that jazz, flashlights, digital cameras, evidence bags. The evidence bag is a surprisingly low-tech device. They can even be a paper bag you staple. They don't have to be like hermetically sealed or impossible to open. They just record that I put it in here, I closed it, and then I took it where it was going, and I was the one that opened it. It's just a record of who did that. It doesn't have to, it's not like impossible to mess with. It just gives you reasonable confidence that nobody's messing with the evidence after you seize it. And then your software, imaging software like FTK Imager or many others, and then software to analyze it, like what we're using here, Autopsy, which used to be called Sleuthkit and Autopsy, now they just call it Autopsy, and many, many other versions like FTK and EnCase, and there are many others like Blacklight and Xways, many other software products that will analyze the evidence you gather. Virtual machines are often important. No anti-stat. Yeah, there should be anti-static up here someplace. Yeah, an anti-static mat to take apart things on. I think it's on the list. All right, and they're talking about password cracking quite a bit in your book. I wonder how often a forensic person would really crack passwords, but I know you try some things, like you try every word on the hard drive. You might have to crack encrypted things now and then. On the evidence bags, yes, there are anti-static evidence bags. That might be a good idea too, you're right. Those pink ones, those anti-static bags would be better for hard drives and such. Then there's photo forensics. JPEG is the most popular format, but there's a lot of others like GIF, PNG, and bitmap. And you want to recover photographs from the evidence you've got. And we see that Autopsy does that automatically. JPEGs in particular are also called EXIFs, and they contain metadata. They automatically record extra information along with your image, like the software recording it, often the time and date, and often even the GPS coordinates of where it was taken, so that can be extremely useful. And most photographs taken by cell phones have this metadata automatically added to it. So photographic evidence, you can, as you've seen, you can see it right there in your forensic software easily, and that's very important. Photograph evidence is very impressive in court, easy for people to understand, far better than some complicated technical analysis. And there's a tool that can reconstruct photos. They're now measuring this adroit forensic. I've heard a few of these tools. See, normal forensic tools, they just go into the unused sectors where covered deleted files. They find the start of a JPEG, the header. They find the end of a JPEG, and they just connect all the in-between blocks and call that the JPEG. Now, if the disk was fragmented, you will have extra junk in the middle of your JPEG. The JPEG really goes from sector 1002, 1003, 1004, and then picks up at 1010, and it's something else in the middle, so your picture will just have stripes in the middle of it. Most people just don't care. 90% of the images are okay and the others are messed up, and you accept that. There are a few products that will actually try to reconstruct it in more detail. It turns out to not really be a valuable market sector to make these products. It turns out the actual additional evidence is not really worth much to people. But anyway, there's one of the products that can do a better job of recovering images if you wanted to. And then, of course, you've got to have a lot of energy to run these powerful machines in your lab. And you got to have fire extinguishers, of course, for electrical fires too, which you might have. And it's bloody expensive. All this stuff is expensive. The safes, the hard drives, the machines. It's expensive to run forensics at the standard which people do it. And you have to restrict access to the lab. Obviously, you can't have random people wandering into the lab. You're going to have to testify in court that I analyzed this thing and nobody messed with it and put extra data on there. So you got to have it locked up and have proper, like you would in any server room, mag stripes, and video surveillance or something like that to keep track of who's going in there. And so you have access control to make sure who's allowed to get at the data so it's not exposed, because that is usually confidential stuff in the data. And I see physical security and lab access auditing. You should have auditing of who's going in there. So you'll have a laboratory sign in and sign out, and often something like magstripe cards or video surveillance too, to make sure you know who's been going in there. And you locate it, of course, in a physically secure place, not a place where the building's going to collapse or something. All right, so then you have to extract evidence. You typically use a Linux tool for this, although we can use Windows tools too. Let's see, Linux is quite important in all computing. You can't really get very far in computing of any kind these days without knowing some Linux. Now that all cell phones are running Linux or Unix, and almost all portable devices, you can't escape it. There was a time, maybe 15 years ago, when you could really say Windows is all that matters, but that's over. Linux and Unix are all around us these days. So, for financial fraud, you'll be looking for financial information like credit card numbers, and there's a certain format for credit card numbers. So there's a major industry identifier, which I think is the first character, and then the first 6 digits of the credit card give you ranges to tell you what kind of credit card it is. And there are other patterns to credit card numbers. They're internal checks. And check fraud, there's these check numbers that matter, the bank number and so on. There's a pattern to that stuff too. And skimmers. If you read Brian Krebs' blog online, one of his big interests is skimmers and Russian cybercrime. And he knows all about them. Skimmers are all over the place. They go to a place where credit cards go in, like a gas station or a bank ATM, and they get a device. You can buy them on forums for a few $100 that fits perfectly over the top. You can even get one that's the right color and everything. It fits on the top and makes an extra copy of your credit card magnet stripe as you push it in. And it can do something like send it through short-range radio to a guy waiting in a car, or save it on a thumb drive that he'll come recover later, or something like that. So they say, before you use a place where you put your card, you should try tugging and yanking and seeing if it's really fake. These things go in patterns. Anyway, there's a lot of them. And some of them now also have cameras to record the PIN as you type it in. So another reason why it's a good idea to have the modern cards that are chip and pin, where it does not use the mag stripe, but it uses the PIN. However, there's still a mag stripe on the card, and if I read it, I can still make purchases with it. So removing the mag stripe and going to only the PIN might be better. I've seen those Apple cards. I don't know if they have a mag stripe in them. Anybody got an Apple credit card? They look real pretty. I wonder, maybe they don't have a mag stripe on them anymore. If so, that would be a good security benefit. Yeah, you got one. There's no mag stripe, right? Is that a mag stripe? Yeah, okay. Silver thing, huh? Yeah, probably is. Yeah. Anyway, all right. And of course, the Secret Service is heavily involved in that. Counterfeit money and financial crime is a big area of the Secret Service. And steganography is another thing to know about. You can hide data in a file. You can take an image and you can change the colors of some of the pixels a little bit to hide another message, like a text message in a picture. This has been around forever. It's used by terrorists and spies a lot. Anna Chapman used it. The Russian model who went to Washington, Russian spy who went to Washington, seduced people and got them to tell them her secrets and sent it back, hiding it in steganography. But she got caught and she fled the country. She left her computer behind, and they found the software on her computer that did the steganography. So they got in that way. But she went back to be a hero in Russia. Anyway, so there are tools to try to find steganalysis that can find it if you're using standard techniques, but it's very easy to write your own steganography program, and it's almost impossible to detect. The only way to do it is if they can find a copy of the image before you modified it and get the bits that are separate and then try to guess what they mean. But in principle, you could have any pattern of bits encoded any way you want. You could make it very difficult. But there are some standard tools people use, and then you can catch them if they're using the standard tools. All right. Well, that's it for that lecture bit.